Hi, good morning, guys, and welcome back to our video tutorial. Like as we started before, we just have a continuation of the chapters as the pandemic goes through. Continues to strike. So, but nonetheless, like I said, we have to continue, and I welcome you guys to our video tutorial, and I hope you guys enjoy the videos and you follow suit. Okay, guys, good morning, and that's a cup of tea for you guys, so you can just take a cup of tea whilst you're listening, and then try to have a pen and a book with you whilst you're listening. You can be taking some notes. Yeah. Okay, guys. So today we are going to talk about network protocols and communication. So I'm going to be pretty much fast in what I am going to do. What you will do is make sure that you have a pen and a paper, or a pen and a book, and you take note of some of the things that I will discuss. So the network protocols are simple as the rules of network communication. So we have rules in communication in both human and network devices. So we're just going to be talking a very fast way, but you guys can pause and take notes, and then you continue. Make sure that you make some research and do a lot of reading at home before we get back here. So guys, that is the chapter, and we go straight to the objectives of this chapter. What we are supposed to complete today before we finish this video is to talk about rules of communication and the network protocols and standards. There we will explain the role of the protocols and standards that organizations in facilitating interoperability in network communication, and we'll explain why protocols are necessary and explain the purpose of adhering to protocol suite. We'll explain the role of standards organization, and we'll also explain how TCP model and the OSI model are used to facilitate communication, and why we also have those models. So the last side is we're going to talk about data transfer. So basically there is no practical for this particular chapter, but in our subsequent chapter, like the next video, we will have practical, that will be physical practical, that is how to crimp cables and punching and so on and so forth. And that one, maybe if we come on site, we're going to do that again. So I'm just going to make a quick one. Alright, so rules of communication are the protocols in communication are the rules that govern the way communication is conducted. So in every communication there are three elements that are very vital, especially in human communication: the speaker and the listener, that is the source and the destination, and we also have the media in which they communicate. So these are what we have in human communication, and we have rules or protocols that govern all methods of communication. In human communication, we have the sender and the receiver and the transmitter. So the transmitter, if for instance I am speaking in a different language that my recipient does not understand, I will need a transmitter that translates my Mandinka to my Wolof or to my English or whatever. So in computer languages we have similar thing. Okay, the medium for the computers is a cable. In human communication it will be the verbal or any kind of communication. So the rules that establish communication are those necessary for effective communication include to identify a source and destination of the communication, identify a common language or grammar. Like for instance, I'm using English right now. That would help me to encode my communication to you guys, so you guys can decode my communication. So encode here means, I'm using encode, it means to give information in a format that the recipient will understand. Speed and timing of delivery is also a fundamental aspect of effective communication, and also confirmation or acknowledgement requirements. So when we go to network communication, this side is about human communication. So let's go to computer communication or computer network. In computer network, the fundamental part of communication here is message encoding. That means to put the message in a format that the recipient will understand. The delivery option, we have different delivery options. We have one-to-one delivery option, we have one-to-group delivery option, and we have one-to-many delivery options. We also have message formatting and encapsulation. The message formatting and encapsulation are different kind of things. That is how the message is put and how it is understood. Then encapsulation is the message put into a message. Let's say for instance you have an envelope and you have a letter. Putting this letter into an envelope, it means you are encapsulating a packet inside an envelope. So message timing and message sizes we'll talk about. So it's very important that these things are fundamental, necessary things that should be included in communication. So message encoding, like I said, is to put the communication in a format that the recipient will understand. So that is just what encoding means. So let's say, for instance, if I am speaking to you guys, I speak in Fuller. Maybe some of you guys cannot understand Fuller. You will need a translator that will help you translate. So that translator will encode to your language, and then you will decode. Okay. So I will encode, and your translator will decode for you. So that's why you have your transmitters and decoders. So message formatting and encapsulation, like I said, encapsulation is the process of putting content into another. Let's say, for instance, like this example, you have a letter, and this letter inserted into an envelope. And the message size. Message size is very, very important when communication is ongoing, because if I give you too much of information than you can receive, then that will be a bad thing. So if you want to understand, if for instance I can send 50 words at a time in 1 second, I can speak 50 words in 1 second, which I don't think is possible, but let's just give an example. And then you that is receiving can only receive 10 words in 1 second. In that case, my 50 words 1 second, I am going to divide it into 5 different pieces, so that you will also understand. In that process is called segmentation. So we'll talk about segmentation tips. I have a large piece of data or a large piece of information that I need to give you, but you cannot understand all of this at the same time. You cannot receive it all at the same time. I'll have to break it for you. Okay guys, so we have timing, message timing, we have access method, flow control, and timeout. The access method is, you will need to know if your recipient is available before you make that call, or before you communicate. Before you send a letter, you must make sure that your recipient is available and he is able to receive. That is access method. The flow control is that the source, that the person that is speaking and the person that is listening must negotiate correct timing to avoid the destination getting overwhelmed. Let's say, for instance, I don't ask you to know how much of information that you can receive at a time, and I sent everything. I can get you confused, I can get you overwhelmed. So flow control is how much of a data can the recipient receive at the same time, and then I send that. That is flow control. But this, if you come to flow control and error control in TCP, or sorry, in transport layer, we'll discuss that. And the response time out is, if for instance I'm on a phone with you, I said hello, and then 3 seconds no response, another hello. So it's like the phone is there, the call is on, but when I say hello there's no response. What happened? I'll hang up. So that also applies to your servers. You're trying to reach a server and it's not available. As time goes on, it will say request time out, because there is no response. So like I said, the delivery method, we have 3 different types of delivery method. We have the one-to-one delivery method called unicast, we have one to a group called multicast, and we have one to all or one to many as broadcast. So unicast is, for instance, you are in this classroom, I say get, can you explain this to me? I name a name from the group of names, and then I directed my question to that name. So therefore I am unicasting my communication. Nonetheless, that all others in the class will understand or will know that I am speaking, but only get that I named will respond. Or let's say, for instance, that is unicast. Now let's talk about multicast. For instance, I have a group, I have a classroom, and I have 2 parts of this classroom. I call one part as group A, and I call another part as group B. So those on my right, for instance, are my group A. So when I say group A, can you do that? So when I say group A, the entire class would hear me, but only group A are responsible for responding to me, because that way I directed my communication to a specific group in among many. So that is multicast. Broadcast is just like I'm on a radio station and I'm just talking blah, 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 or I'm in the classroom and I just post my questions, or I just talk to everybody in the classroom. That is, I am talking to all. I am broadcasting my message. Okay guys, so network protocols and standards, we talk about those ones. Now the protocol suites are implemented by host and networking devices in both software and hardware. Why do we have this protocol suite? This protocol suite help computers to communicate even though they are not from different vendors. So that's what these protocol suites are. So we're going to talk about different protocol suites. So first we're going to talk about the IP, the TCP, and the IP. So network protocols define a common format and set of rules that would help in exchanging messages between devices, and that's exactly what these protocol suites are. All that they do, they allow your computer to be able to communicate with another computer. There's no problem. So common networking protocols, we have different networking protocols. We have application layer protocols, we have transport layer protocols, we have network layer protocols. We have different protocols. So but we just have few examples like HTTP, TCP, IP. All of these let's say for instance when you talk about the TCP IP, we got those ones. With the TCP IP, because it is just 4 layers, so we have application layer, transport layer, internet layer, and the network access layer. So the HTTP is application, TCP is transport layer or host to host layer, and IP is internet layer. So we talk about those ones.